for another free video for Windows 7, part of the free training course for the 7680 exam. In this video, I will look at dynamic disks and RAID. One terminology I want to make clear before getting started is the difference between a partition and a volume. Understanding the difference between the two becomes important when dealing with data that is spread over multiple disks. A partition, in simple terms, is dividing a hard disk into multiple storage areas. This may be done for a number of different reasons. In some cases, you may want to separate your operating system from your data. Multiple partitions can be used to keep your virtual memory or paging files separate from the operating system. In systems such as Unix, this is quite common. Storing the virtual paging file on a separate partition on the same hard disk as the operating system has little to no speed improvements. To get speed improvements, you are best to put the paging file on a separate hard disk from the operating system. If you are running multiple operating systems, you can use partitions to keep these operating systems separate. With virtualization becoming more popular, this is not happening as much. If you wanted to run another operating system, it is easier in most cases to run the operating system in a virtual machine rather than creating multiple partitions on your hard disk. A volume is different from a partition as it is defined as a single accessible logical storage area. It uses partitions as its building blocks to build a volume. This means that a volume can use one partition or use multiple partitions on multiple disks. The key point to remember is that a volume is defined as one storage area. To put it another way, a volume will appear in Windows Explorer as one drive, regardless of how many disks and partitions it uses. When you use disk management in Windows 7 to create a volume, disk management will automatically create any required partitions for that volume. You may not have even known that partitions had existed before now, as disk management does a great job of doing all the hard work for you. When you first install a hard disk in Windows 7, it will be installed as a basic disk. Basic disks are supported in all versions of Windows, so offer great compatibility. With a basic disk, you can shrink or extend the volume. In other words, you can make it bigger or smaller. You can even shrink or extend the system or boot partition. The next disk type that Windows 7 supports is dynamic disks. Dynamic disks support more features than simple disks, however, do require Windows 7 Professional or above. Since dynamic disks are a Microsoft solution, alternate operating systems will not be able to read dynamic drives. Besides having more features than basic disks, the big difference with dynamic disks is that it uses logical disk management. Logical disk management, also referred to as LDM, reserves a small part of the hard disk to write additional configuration information about the drive. This information is replicated to all the other dynamic hard disks in the computer. The information in the LDM contains information about hard disk drive management. This means that if you move the hard disk from one computer to another computer, the hard disk drive letter will be remembered. Also, if you move the hard disk from one controller to another, the drive letter will also not change. If you are currently using basic disks, you can convert your basic disk to a dynamic disk. This is a one-way process, so you will not be able to go back to basic disks without losing all the data on the drive. Dynamic disks support multiple hard disks combined together to form a set. The first way this can be done is using a spanned set. A spanned set combines all the free space from multiple drives into one logical hard disk. The free space on each drive can be different sizes and is a good way of making use of free space without having to create multiple drives, each with their own drive letter. Creating a spanned set allows you to use the free space that may have otherwise been wasted, but it does not give any performance improvements. Also, if one drive fails in the set, all the data in the spanned set will be lost. The next type of disk set that Windows 7 supports is RAID. RAID, or redundant array of independent disks, is when multiple hard disks are combined together for performance or redundancy reasons. There are a lot of different ways RAID can be configured. Windows 7 supports two of these. These are RAID 0 and RAID 1. One thing that I want to point out is that Windows RAID support is software. Nowadays, a lot of hardware supports RAID. If you are thinking about using RAID, consider looking to see if your motherboard supports hardware RAID. Hardware RAID generally performs faster than software RAID. RAID 0 is often referred to as a striped set. RAID 0 is when the data from the hard disks in the set are evenly spread out over all the drives in the set. As shown here, files on the hard disks are divided up into parts and stored on the two drives. You need at least 2 hard drives to have a RAID 0 volume, or striped set, but you can have more. As shown here, if you had 4 hard disks in the set, the data is once again spread out over all 4 drives. The advantage with multiple hard disks is that read and write performance is increased. As shown here, when you read from the RAID 0 drive, all hard disks work at the same time to read the file. Also, if the file is updated, once again, all hard disks write at the same time to update the file. There are 2 disadvantages with RAID 0 drives. The first is that if one of the hard disks were to fail, then you lose all the data in the set. The second disadvantage with RAID 0 drives is that you cannot boot Windows 7 from a RAID 0 hard disk. If you want to do this, you will need to use a hardware-based RAID solution. This is because RAID 0 in Windows 7 is software-based. The operating system must boot first so that Windows can access the drive. For this reason, RAID 0 drives are usually used for data drives or even for the paging file. If you decide to use RAID 0, remember that all your hard disks in the set must be the same size. If you use hard disks of different sizes, the RAID set size will be a multiple of the smallest hard disk in the set. The additional space on each hard disk will not be used in the RAID 0 set and will remain unallocated space. The next type of RAID that Windows 7 supports is RAID 1, also known as a mirror set. A mirror set requires 2 hard disks to operate. The advantage of RAID 1 is that the drive can still function if one of the hard disks were to fail. Since both hard disks contain the same information, there is no problem booting from a RAID 1 hard disk, so you can use RAID 1 for the operating system and data drives. The disadvantage with RAID 1 is that there is no performance advantage. You get redundancy by having your data in 2 places, but in the process, your data costs effectively double. Now that you understand the basis of basic and dynamic disks, let's take a look at how to use them in Windows 7. First of all, I will open the Disk Management tool from the Start menu by running diskmgmt.msc from the Start menu. In this computer, I have put in another dynamic hard disk from another computer. Notice that this disk has come out as foreign. If the disk were a basic disk, it would not come up as a foreign disk, it would appear as another disk. The extra configuration data on the disk provided by Logical Disk Management allows Windows to recognize this hard disk as from another system. To make this hard disk accessible on this system, right-click and select the option Import Foreign Disk. Once selected, Windows will tell me which disks are being imported. Since this is a dynamic disk, it could be one hard disk out of a set of hard disks. If any hard disks were missing, Windows would inform me, since the configuration information for the set of disks is stored on every hard disk in the set. Once I press OK, I will be given a dialog telling me which volumes on this hard disk are being imported. Once I press OK, the hard disk will be imported. Notice that when the hard disk is imported, it is given the drive letter T. This is the drive letter I assigned this hard disk on the other system. Thanks to the extra information stored on dynamic disks, Windows is able to determine the drive letter of the hard disk. I don't need the data on this hard drive, so I will go ahead and delete the volume on the hard disk. Disk 0 on this system is a basic disk. Notice that when I right-click disk 0, I have the option to convert this disk to a dynamic disk. In this case, I will leave the disk as a basic disk to prove a point. When I right-click on the system reserved volume, I get the option to add a mirror. This is basically making the volume a RAID 1 drive. When I select Add Mirror, Windows will give me a list of all the hard disks that have enough space to store the mirror drive on. When I select a drive and move on, I will get a message telling me that the hard disks will need to be converted to a dynamic disk before I can continue. Since Windows will prompt you anyway, you don't need to worry about converting your hard disks to dynamic before setting up a mirror set. Once I press Yes, I will get another dialog telling me the boot configuration of the drive could not be updated. What this is basically saying is that Windows will be able to boot off disk 0. However, if disk 0 were to fail, the system will not boot until you modify the startup configuration. This can be done using BCD Edit, using a Windows PE boot disk. This is a limitation of Windows to boot from mirrored drives. This is why I would personally use a hardware solution to mirror the system drive. If I select one of the volumes that is on a dynamic disk, notice that I have the option to shrink and extend the volume just like I had with basic disks. If I go down to one of the free hard disks and right-click it, I get the option to create a new striped volume. A striped volume is RAID 0. Once I select this option, the wizard will start and I'm asked which hard disk I want to use in the striped volume. In this case, I will select 4 hard disks to use in the striped set. Just like when I created a simple volume, I will be asked for a drive letter, volume name, and formatting options. Some of the hard disks are basic, so Windows will ask me to upgrade them to dynamic before continuing. The new striped volume has been created and added as RAID 0 in the Disk Manager. The other hard disks in the system were 50 gigabytes and this hard disk is 128 gigabytes, so you can see at the end of this hard disk is 77 gigabytes of unused space. If I scroll up to the top, there are 3 drives with space at the end that is not being used. To combine all this space into one drive, all I need to do is right-click on some of the unused space and select New Spanned Volume. This will start the Spanned Volume wizard. The wizard works much the same as the other wizards. Select the hard disks you want to use, configure the drive letter, volume, and formatting options, and complete the wizard. The drive is now created. Windows 7 color codes each drive to make it easier to use. The legend is located down at the bottom of the screen if you are not sure which is which. Like with simple volumes, it is a matter of right-clicking the volume and selecting Delete Volume if you don't want the volume anymore. If I right-click the mirror drive that I created earlier, notice I have another option, Break Mirrored Volume. If one of the hard disks in the mirror were to fail, you could select this option to break the mirror. If both disks are present and you no longer need the mirror drive, select the option Remove Mirror. If I right-click on some free space again, notice the option New RAID 5 Volume. This option is grayed out. I have not covered RAID 5 in this video because Windows 7 does not support it. To use RAID 5, you need to be using Windows Server, so don't worry about trying to figure out how to enable it in Windows 7. This concludes the more advanced features of hard disks in Windows 7. In the next video, I will look at the disk defragmentation tool. As always, for additional free videos, check out our YouTube channel or webpage. Thanks for watching.